Hey everyone, Katrina here, and today I'm going to show you how to solve reciprocal trig equations. Be subscribed for more videos like these and watch to the end to see the full example. Okay, the first thing I want to say is I do not want you to be afraid of reciprocal trig equations. If you see something like cosecant theta, secant theta, cotangent theta, just know that they're simply the reciprocal of our familiar trig equations. So cosecant equals to 1 over sine theta, secant is 1 over cos theta, and cotangent is 1 over tan theta. So they have wonderful relationships with each other, and there's no need to get worried. And I'm going to show you an example today how we can solve one of their equations. So the example we're going to look at today is we want to solve for theta, so where theta is between 2 pi and 0. So we have our domain set and we want to solve for theta. Okay, and we want to give an exact solution where possible. So that means whenever you see exact, you should already be thinking, is there a special triangle that I can use? Because special triangles are a secret weapon to help us give exact answers. Okay, so let's start with this. So we've set up the problem, and the specific question says that we have cosecant theta equals to negative root 2. And we want to solve for our theta. Okay, so let's consider our trig ratios. Again, if you need some background with this, please watch my trig ratio video. So just for reference, we have that sine theta equals to y over r, which is our opposite over hypotenuse, and r is our radius. So if sine equals to y over r, and we said that sine is the reciprocal of cosecant, that means that we can just flip the ratio for cosecant. So cosecant theta simply is going to equal to our radius over y, or our hypotenuse over, this should be opposite, not theta, over our opposite. So always write down your ratio before you start, because that will be the key to your success. Okay, so let's look at our specific problem here. You say we just have one number. How can I have a ratio? Well, the secret here is that always put your number over 1, because the 1 will help you see it in terms of your ratio. So we said that cosecant is r over y. But r can never be negative. You can never have a negative radius. So you can kind of think of this as root 2 over negative 1. And that will help you see it as your radius over your y value. So do that immediately, because now you've just demystified this entire scary looking reciprocal ratio, and now you have it in just very plain terms. So following our steps, we first want to set up our unit circle and write down all of our important information. So first, starting with the domain, we know that we're going from 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. So we're completing one full period. And let's write out our cast rule. So we'll write our quadrant numbers first. So we have quadrant 1, 2, 3, and 4. And then we'll write out our cast rule. So we've got C, A, S, T. And our cast rule tells us which ratio is positive or negative in which quadrant. So here, the reciprocal ratios follow the same cast rule as a primary. So sine is positive in the A quadrant for all and the sine quadrant. So that means it's going to be negative in the bottom 2. So if sine is negative in the bottom 2, so is cosecant, okay? So let's draw that out there following our bow tie rule. So we've got this and this, and we have to write down our angles or the side lengths. So we always create right angle triangles. And now let's fill out our ratio. So that means that we've got our r value, our radius is root 2. And our y value, or vertical value, is negative 1. So the next step is to check for special triangles. So this here is a special triangle. I can tell by its pattern of having root 2 and 1. That means we can fill this in with 1 and 1. And then the angle here, I'll show in radians, is going to be pi over 4. So if you need some help with special triangles, be sure to check out my special triangle video. Just so you know, we're working with this guy over here. So we got our 1, 1, root 2 triangle, and the two angles within it are pi over 4. So a nice isosceles triangle. Okay, so this pi over 4 is what I call the internal angle, or we can call this alpha. Okay, so we need to find our theta. So we're going to have two values for theta. So how this works is we always start at our principal axis, which I am highlighting here in yellow. And then from there we move counterclockwise until we reach the radius of our triangle. So from here we're going to move around. So this over here we'll call our theta 1. And then we need to go all the way around to our second radius, and that will be our theta 2. So how can we find these angles? So in my previous video I showed a pretty cool trick that you can use. And you use basically your axes as reference points. So the first angle we want to find is in quadrant 3. So the equation for that is we would take pi as our reference plus our alpha, our internal angle, will give us theta 1. And our second angle of question is in quadrant 4. So there we use 2 pi as our reference angle minus our alpha to get our theta 2. So let's go ahead and just fill these in. So here we'll have pi plus pi over 4. Using a common denominator here, we get 5 pi over 4. And that is our first answer. And secondly, we have 2 pi minus pi over 4. Finding a common denominator, we can make this 8 pi over 4 minus pi over 4 equals to 7 pi over 4. And that is our value for theta 2. So you would write out your final answer saying, therefore, theta 1 equals to 5 pi over 4 and theta 2 equals to 7 pi over 4. I always recommend that you check that your final answers are still within your 0 to 2 pi domain. And in this case, they are, just to be sure that you've done everything right, and it's a great final check. So here I showed you how easy it is to actually solve an equation when you have a reciprocal ratio. All you have to do is simply swap the ratio, flip it over of your primary ratio, and then set up your triangle, and voila, you have your answer. So this is a great step-by-step process that you can follow on a continuous basis. If you have any questions, please drop them in the comments, and be sure to consult my other videos if you have specific techniques that you're looking for, and please subscribe for more. I'll see you next time.